Thank you, Alan. Thank you, everyone. Thank you. Well, it is an honor to be the first to welcome you to CascadiaJS. Thank you so much. Just kidding. Actually, it's been a really wonderful conference. Saw some really great talks. Dave Foley has a huge beard since the last time I saw him on news radio, which was years ago. David Bruin had a talk, JavaScript Regrets, about long list of huge mistakes. I'm looking forward to the sequel called Tom Dale's Love Life. Anyway, as Alan said, it's all just bad stand-up from here. I'm really sorry. As Alan said, I'm Tom Dale. You maybe recognize my avatar from Twitter. If you guys have any questions or you want to chat after, please come find me. Or if you want to do it online, this is how to get a hold of me. And I think maybe the thing that I'm best known for probably is Ember, which is a JavaScript framework that I help work on. But I think the thing that I care about the most, and the thing that this talk is going to be focused on primarily, is URLs. So URLs are a really big theme of this talk, and I think they're a very important thing that, as web developers, especially JavaScript web developers, a lot of us have done a very bad job of taking into consideration, and I count myself in that group. But I'm here to repent, and I'm here to spread the message to you, and hopefully we can get you all back on the URL religion. So before I talk about URLs, though, I actually want to talk about phone numbers. I want to talk about the idea that when you want to talk to someone on a telephone, the fact that you pick up this device and you punch in a series of numbers. Now, you took it for granted. Presumably, most of you were born in the 1900s. And so you just kind of accept it as a fact. You were taught at a very young age that to dial someone, you dialed in a phone number. But you probably didn't think about how that whole system came about. And it turns out that the way that phone numbers came around is because of measles, the disease of measles. Now, I was going to put a nice little graphic to go along with this slide, but because I actually have no idea what measles is other than disgusting. So please don't type this do a Google image search for this. So telephone numbers. So you might be wondering, what does this have to do with computers? I'll get to that in a second. The first thing I want to ask you is, does anyone recognize this gentleman here? This is Alexander Graham Bell, who, if you believe the history, is credited with being the first person to invent the telephone system. Now, the first phone call in the entire world was between Alexander Graham Bell and his assistant. But he didn't need a phone number to dial his assistant because he literally had the only two handsets in the world. They were wired directly together. As you can imagine, this is not what we would call a scalable solution. So they had to come up with some way of telling the system who you want to talk to. So what they came up with was this telephone exchange. And they invented the telephone exchange. And the way this would work actually is there were no phone numbers. What would happen is you would pick up your handset and it would connect you directly to an operator sitting down at the local central office. And what they do is they would ask you for the name of the person that you wanted to talk to. But look at this bank. There's so many people connected here, and there's not room to label each of these by name. So it was actually a pretty complicated and lengthy process of, I asked for someone by name, and now they have to figure out which circuit to patch my circuit into so we can talk to one another. And it was actually during a measles outbreak that this is the late 1800s, when things like measles outbreaks were, as a business owner, you had to worry about them. So they're like, if a measles epidemic breaks out, measles, by the way, I learned is really contagious. Look at how close these people are to one another. If one of them gets measles, they're all going to have measles. And they were afraid that this disease was going to totally cripple the communication infrastructure, primitive as it was at the time. And so there was a physician who actually was like, you know what, if all of these people are out because of measles, it'll be a lot easier to train replacements and get them in there, and a lot cheaper. We need less skilled labor if all we do is have the user ask for the phone number, give the number, give the index, and then instead of having to look it up and cross-reference the name to the number, they just give it to us and we'll plug them directly in. So because of measles in the 1800s, they switched from you being able to tell by name who you want to talk to. Now you are responsible for giving the phone number. And one thing I thought that was really interesting when I was researching this is, so this obviously increased the efficiency of the system, but I found out that for long distance calls, if you want to do a long distance call, you would actually, there was like a hierarchy of different central offices. So you would have to traverse, your phone call would traverse manually through all of these central operators. A long distance call, on average, before you were even connected to the person on the other side, was 15 minutes. So you really, really had to be like excited to talk to that person because you're sitting there doing nothing for 15 minutes. It had to be a very important call. So the interesting thing I think about the phone number is that if you think about like the smartphone in your pocket, you think about your Android phone, you think about your smartphone, the way that you call someone, if you go to your address book right now, you have a phone number for every person in that address book. If you meet someone for the first time and you want to stay in contact with them, the thing that you ask for is their phone number. But of course, the central office as a system doesn't exist anymore. The whole phone infrastructure has been completely replaced by something that's automated, it's digital, it's electronic. But still, here we are in 2013, and we have the notion of the phone number. And I think that's a really interesting thing, because I can go to any country in the world, I can use any device, I can pick up a phone that I've literally never seen before, and I know how to operate it. In a lot of ways, what the phone number is, the way that I think about the phone number is it's the universal UI of our phone system. It doesn't matter where I am, it doesn't matter what the underlying implementation is, it doesn't matter what device I'm using. I know that there's a keypad, and if I punch in the right phone number, I'm going to get someone on the handset. And I think that you can draw an analogy between the phone number and the URL in the web browser. So I think a lot of people think of the browser as being a program that you run that, it can render HTML, it supports CSS, it can run JavaScript. But that's not how I think about the browser at all. To me, the browser is just a box with an address bar and some content below. Now, right now in 2013, it happens to be JavaScript, HTML, and CSS. But to me, that is just an implementation detail. And I think there's an interesting thing that fell out of the browser, which is that, of course, when the browser started, it was just a document viewer, right? Like when Sir Tim Berners-Lee invented the browser, he did it so he could share documents with his colleagues. And the fact that we were ever able to build applications on top of a document viewer is actually pretty crazy. And what it meant is that if the browser wants to ask the server for something, it has to have some mechanism of telling it what it wants. So if you are building a server-rendered web application, literally the first thing that you have to do is think about URLs, right? Like if you're building an app in Node or in Rails or in Django, the first thing that you have to think about is URLs. If there's no URLs, there's no app. But I think that if you think about this architecture where so much decision making and so much rendering and there's so much shared state between the browser and the server on the back end, this entire thing is a huge, huge hack, despite the fact that billions of dollars of our global economy is built on it. At the end of the day, this is a hack. And I think it's important to understand, I'm not using the word hack here in the pejorative sense. How many of you saw Apollo 13? Okay, so in Apollo 13, it's like, holy crap, there's like this emergency, we've like vented out all of this oxygen. We need some way, we have to go into the capsule, but we don't have the right CO2 scrubbers. So all of the engineers at NASA like huddle in a room for hours and like trying to figure out how do we get the round CO2 scrubbers into the square pegs. And it's amazing. It's like, holy crap, that was amazing. Human ingenuity at its finest. Maybe in Apollo 14 we shouldn't have to go through this exercise. Maybe if we have the opportunity we can do something a little bit better. So I think that's why we're all here. We're all JavaScript developers and we're here to build really awesome JavaScript applications. But there's something about JavaScript apps, which is that because it's all happening on the client, you don't need a URL. You can write a completely functioning JavaScript application that downloads and runs in the user's browser. It doesn't need URLs. Nothing's going to break because everything is local. And I'm guilty of this. I worked on Sprout Core, JavaScript framework. I worked on the iCloud apps at Apple, which had very poor URL support. And even the very first versions of Ember that I worked on had really bad URL support. There was no router. There was, in fact, no router built in. And I think that other JavaScript libraries are just as guilty of this. And I think that's really bad. I think the more that I've thought about it, the more that I've realized if you don't have URLs, you are losing out on so much. So sharing is the obvious one. Like URLs are obviously a sharing thing. Like, look, just open up Twitter, open your inbox and email. you probably don't even take for granted how many URLs fly by you every day. And collaboration, I think, is an important corollary that comes out of sharing, right? Like, if you think about Google Docs, you send out a link, boom, we're all on it, we're all collaborating, and there's not a really painful setup process to go through. Bookmarking is one, and I think one that people don't think about a lot or talk about a lot, but for me is one of the most amazing things about the web, about using web applications, is the fact that you can fork whatever you're doing. Like, probably many of you, you log into Gmail or you log into some kind of task management thing. You see something, you're like, I can't do that right now, but I'm going to get to that in just 1 second. So you command-click it, and it opens up in a new tab. Can you do that in Photoshop? Can you do that in Microsoft Word? No, I don't think I've ever used a native application that lets you kind of fork off what you're working on and create all these instances of the application and save the state. And yet, that's something that happens in almost every web application you use every day, and that's amazing. So I think that URLs are incredibly important, but we face a future where if we don't take them seriously, if we don't care about them, then I think the web can lose a lot of the strengths. I think in a lot of ways, URLs are the thing that let the web win on the desktop. Right? Probably most of you spend the majority of your day in web software instead of native software on your desktop computer. That wasn't guaranteed to happen. It didn't feel like that in the early 2000s. So I think an important question to ask yourself as we're kind of moving away from the server-rendered architecture towards much smarter clients, and I think we need to ask ourselves, what is a web app? And I think the best way to think about the answer to that question is to think about, well, what is a native application? If I were to ask you, give me a list of things that a native app would have that a web app doesn't have, you'd probably provide a list that looks something like this. So this is actually good. Basically, now everyone knows what IEEE 754 floats are if you were here this morning. So you can open a socket to an arbitrary server, right? You can allocate just a slab of memory in the heap, and you can be in charge of manually managing that memory yourself. You can do 3D accelerated drawing. You have concurrency. You can deal with integers and bigger numbers. And if this is your definition of what native apps are and what native developers have to deal with, I have really bad news for all of you, which is that by this definition, you are all actually native developers, because these are all features that are shipping in browsers today. These are all things that you can take advantage of today. So I think that if you ask yourself, if I use technologies like HTML, CSS, and JavaScript, is that the thing that makes me a web developer? And my answer to that is no. My philosophy on this is that you are a web developer if you are building apps that have URLs. I don't care where it runs. I don't care what it's built using. I care whether it's something that I can fork, whether I can share it with my friends, whether I can collaborate. And I think that if you don't have URLs in your application, it's literally no different than just compiling an exe and uploading it to an FTP server somewhere. If you don't have URLs in your JavaScript app, you're just using the web as a distribution mechanism. You're not actually being a true citizen of the web. So I think the question that we ask ourselves then, I think the natural question is, how do we build applications that respond and behave like native apps now that we have all of the features that we need to build them, but how do we do that in a way that doesn't break the web? And I think it's natural to look at those who have come before us and try to figure out how they solved the same problems when they had the same tools available to them. And I think that MVC obviously is very popular. I saw a study the other day. It said in 2012 alone, there were over 17 million JavaScript MVC frameworks released on Hacker News, which is just incredible. So I think we're onto something here. And let me ask a question. How many of you have used some kind of JavaScript MVC framework, whether it's Backbone? Okay, basically everyone. So you all know that there's at least some value here, I think. And so Yehuda and I, in particular, spent a lot of time. We went for many, many walks discussing the fact that it seemed like there was this disconnect between MVC and URLs. And I think the thing, in retrospect, that now slaps me in the face with how obvious it is, but at the time wasn't, was actually how well URLs that you are used to seeing every day map on to MVC. So think about URLs like this. Usually you'll have some kind of identifier identifying the type of resource, like a photo, which is usually associated with some kind of template that you want to render. you usually have some kind of identifier in there which identifies which model you want to display, some kind of unique ID. And then you have sometimes something in the query string that wants to change or kind of manipulate slightly how that thing is displayed, so maybe changing the sort order. So to me, it took a while to figure this out, but I think there's incredible symmetry between the MVC architecture and the URL. So let's talk a little bit about MVC and what it is. So I think you could talk to basically the author of any JavaScript MVC framework, library, whatever you want to call it. And I think they would more or less agree that this is kind of like the minimum viable product of a MVC framework. You'll quibble like, that's like a view model, not a view, whatever. The point is, you have some kind of UI on a native app that's like a graphics context, or on the browser, it's like a DOM element, and then you listen for changes to the model, you go and update those, and then when the user clicks on something, you have an object, which I'll call a controller here, which reacts to that click or that drag or whatever and makes changes on the model, and you kind of have this virtuous cycle, right? So I think at the very, very minimum, something like this is an example of a Backbone app. Probably many of you have written code very similar to this. Probably every Backbone app you've written is just like repeating this over and over again. And like you, I think a lot of people get very tired of writing that same thing over and over again. And so what we have instead of doing this imperatively, we have some data binding code. So this is an example of a handlebars template. This I pulled from an Ember app. So basically you have like an input tag, and it's bound to an h1 tag, right? So you type in the input tag, the h1 tag updates. Awesome. This is much simpler than writing out all this imperative code, and it's much less to write. So the idea here is basically both of these things are backed by the same model. You put that model in the middle, and they stay in sync. Awesome. You can obviously also do a little bit more sophisticated stuff. You can have conditionals. Here's an example using an if helper. Again, if the editing property on the underlying model changes, it will render one chunk of HTML. Otherwise, if it's false, it'll render this other chunk. Pretty straightforward. And here's an example. This is how you'd write the same thing in an Angular app. Angular is a little bit different in the sense that it uses HTML attributes instead of a templating language. But at the end of the day, I think if you look at all of these data binding frameworks, you can distill them into the idea that they're just some kind of template or something like it connected and plugged into some kind of data source. And you can call this a model, you can call it a controller, you can call it a view model, whatever, it doesn't really matter. And I think there's pros and cons. I obviously fall on the side of Ember's pros, but other people would argue that HTML attributes are better. You see that in Knockout, you see that in Angular, whatever, that's fine. There was actually a really great talk at JSConf EU that I saw just comparing the pros and cons of these different binding systems. But I think no matter what you use in terms of the binding system, you're going to be happy. At the end of the day, they'll help you get the job done. I think the interesting thing, though, is that all of these, in my opinion, are minor details. In the greater scheme of things, these are all very minor things. I think there's actually a much bigger issue. In a lot of ways, perhaps you could call it the elephant in the room when discussing all of these JavaScript frameworks. And that is, they say, OK, it's a model view controller architecture, but that doesn't help you answer the question of which model and which view and which controller. And especially if you're trying to build a larger scale application, you're going to end up with some kind of nested UI that looks like this. And if you don't want one big blob of code, if you don't want to regress to jQuery spaghetti, you need some way of managing that. So let's look at Twitter, for example. If you look at Twitter, you have like the main nav bar along the top, and then maybe you have this. OK, so this is like the main nav bar. This is maybe some MVC going on here. Then you also got the sidebar on the left-hand side, and then inside of that, next to that is your main timeline, right? So conceptually, I think if you're looking at this, you say, well, this isn't one big blob. This isn't one model, one view, and one controller. I want some way of breaking this thing down. And the question is, how do you manage that? How do you let the user navigate between different parts of the page and manage these MVC groups, these clusters? Well, I think that the answer to this is URLs. So I think URLs, again, because of that symmetry, are a great way to manage the idea that you have these different groups of MVC. So the question is, if you're building your UI, how do you get from the URL, the model, the controller, and the template? So I want to walk you through an example. I'm going to use a couple snippets from an Ember app, and then I'll talk about how to do this in the more generic case if you're not using Ember. So let's walk through the case of I visit example.com/post/1. And I need the model, the controller, and the template, and I want to wire all these things up together. So the first thing that we do is in our router, we define a post. So this looks familiar, hopefully, if you've used any kind of server web application framework. So we'll say there's a resource called post, and here is the URL that it matches up to. And you can see after the colon, there's kind of like a wildcard that represents the model ID. That's what's going to be extracted out of the URL. And we're going to extract that out of the URL, and we're going to create a params hash. And so you can see this is just the ID of the post model. And then we introduced this new object called a route. In this case, they're linked together. These are underlined in red because they're linked together just by their name. There's like a naming convention here. And this will be passed to a method on that object called model. And all that model's job is it takes the params hash, which in this case is just the post ID of 1, and it's responsible for turning that into an honest-to-goodness JavaScript object that can be passed to like handlebars or Jade or any kind of templating language. And once we've done that, we've now reified each of these three things into real JavaScript objects from nothing more than a URL. So now we have our model that we found from our database, or we could be using anything, right? It could be hoodie, it could be anything. Yeah, there we go. We know the controller because we have a conventional name for it, and we know which template to use because there's a conventional name for that. Now you might be thinking that's really simple. If I was just using like Backbone or Angular, that's something I could just hand code. But I want to show you the case where you have these more sophisticated UIs, where you have these nested templates. So you're trying to build something that looks like this. Well, we've spent a lot of time thinking about how to do nested routing in Ember. And the way that we do that is we support this DSL that allows you to just nest one resource inside of another. And what this does is it conceptually creates these two different groups of MVC things, right? So we'll walk through again. This is the same thing. You're going to /post/1 again, but now instead of showing one or the other, either the list of posts or a particular post, you want to show them both at the same time. So step 1 is there's a post route, and it just returns the list of all of the posts. So conceptually, this is like the parent MVC cluster. And once we have that, that's really all we need. So now we have our model, we have our controller, and we have our template. So now we need to find the thing that renders inside of it. And this is the same process as before. Now it's going to match that post ID in the URL. It's going to extract that model ID out, and it's just going to create a new params hash as before. And just like before, we've got the post route again. And the model hook just takes that params hash, and it reifies it into a JavaScript model object. So now once we've done that, now we've got our store.findPosts, which is the top level model. We've got the controller inside of it, and then we've got our handlebars template, and then the kind of green area just renders into the parent. And now you have this really nice separation of concerns. Now, especially if you're working on a team, one person can work on one part, one person can work on another part, and they're not going to clobber all over each other. And it becomes very obvious and conventional how these things work together. So I think when people talk about MVC as an architecture, they think about it as an application pattern. They think my application is MVC. But I don't think of MVC apps like that. I think of MVC as almost like a component pattern, because your application is built up of lots and lots of different of these MVC groups. And figuring out how to manage those, that's the tricky bit. That's the hard part, I think. The hardest part about building a web application is knowing which components to show when, especially if you want to be a good citizen and you want to have good URLs that you can link to and you can share, and you can bookmark. So I think a good term for this is navigation. Basically, if you have a JavaScript web application that's not just a part of an existing app, it's not just a part of a page, it's not like the checkout form, it's not like the shopping cart for your web application once people have gone through the traditional flow. If you want to build a 100% JavaScript application where it's never round-tripping to the server unless your app needs data that it hasn't seen before, I think you really need to think hard about these problems. So I think MVC and data binding are very cool, and I'm glad that they exist, but they're just not enough if you want to start building these larger JavaScript applications. If you want to build larger applications, you need app structure and you need navigation. You need to answer the question of which model, which view, and which controller. Now, you might be thinking, this is cool, like this guy gets up here. He's basically giving us a sales pitch for Ember.js, which is true. I hope you use it. I would like you to do that. Just go to emberjs.com to do that. Please do that. However, I understand that not everyone wants to use Ember. Not everyone's ready to use it. And maybe you've already made an investment in a Backbone app, or maybe you've already made an investment in an Angular app. And if that's the case, you're going to need help with this. So what we actually did was we took all of the work that we did for routing in Ember, all of the thinking that we did about routing, and we've extracted them into two different micro libraries that you can use. You can use one or the other, although they're the two that taste great together. So these are two libraries. The first is Router.js, which is basically essentially like a finite state machine that can tell which state, which URL you're at, and you can move around it and it will update the URL for you. And then we have another piece called the route recognizer, which is just this thing for essentially decomposing URLs into pieces, doing some pattern matching. So I'll just give you a really brief tour of what the API looks like. I would encourage you to check out the website, check out the README. So the first thing you do is just create a new router. This is JavaScript. And then once you have the router, we provide this DSL that says, so you call the map function, and in the map function, the map method, we provide a DSL for matching. So you basically say, here's the URL I want to match to, and then on the right-hand side is just some kind of identifier. There's nothing magic here. Whatever identifier you provide is what we'll use. And then once you've declared this in the route, once you define the route, in this case post/id, you say, okay, this is what we call the show post handler. And again, this is totally up to you, whatever you name it. There's no magic naming stuff happening here. And then you just define some handlers. And as basically, depending on what URL the user comes in at, we will invoke the right handler. And so the handler has a couple different methods on it that are essentially lifecycle methods that you can implement. The first one is the model hook. And again, the model hook gets that params hash that I was talking about. And your job in here is simply to take that params hash and turn it into a JavaScript model object. Maybe you fetch it over the network using jQuery. Maybe you get it out of IndexedDB, whatever. And then once that thing is reified, then we call the setup method for you. And that's your opportunity. If you're using handlebars, you render the handlebars template, you put it in the DOM, whatever. But I think the thing that's really cool about Router.js is that the whole thing is built on promises. So if you return a promise from the model hook, we will wait until that promise is resolved before we actually pass it to the setup hook, which means that you can use this, and it doesn't matter what underlying data library you're using. As long as the lingua franca of it is promises, it kind of just drops in and works out of the box, which I think is pretty cool. So you should check it out. There's really deep promise support. It supports things like asynchronous transitions. So if the user clicks away, but you're like, hey, you have some unsaved work, are you sure you want to lose it? You can basically pause the transition and then replay at a later time. It's really powerful. Nested UIs, I know, is a big problem that people are running into now in other JavaScript frameworks. Using something like this might help with that. It's all covered in the README. Check it out. Or come talk to me about Ember. I've also got stickers if you see me and you want an Ember sticker of this cute little hamster. So anyway, that's it for me. Thank you guys very much.